So our first very important difference with cosine is the difference in the negatives and how the reflections affect the graph. So on the back of your worksheet, you should have noticed when you had the negative outside the function and you plugged in 0, you got -1, 0, pi, 0, -1. So you should have noticed that the graph reflected over the y-axis, or over the x-axis, as it should when the negative is on the outside. So instead of starting at the top, now the cosine graph starts at the bottom. So the negative on the outside makes the cosine graph start on the bottom instead of the top. Now when you graphed, if I write this outside, when you graphed the one with the negative on the inside, you should have noticed that nothing actually changed. So when you plug in 0, you still get a +1. Pi over 2 is still a 0. It should look exactly the same as the parent graph on the front of your page. So this is a big difference with cosine. When the negative is on the inside of the function, nothing changes. This happens because a negative on the inside is a reflection over the y-axis. And as you noticed on the front half going through the properties, cosine is symmetric about the y-axis. So it just flips on itself. This also is right from the fact that cosine is even. So it's the idea when you plug a negative inside the function, it's the same as not having a negative at all. So if you're ever graphing and you have cosine of -x, you can get rid of that negative. It's the same thing as just a positive cosine graph. So now to go through these two examples on the back to see how you did. So you have -3 cosine pi x. That negative is on the outside, so yes, there's a reflection. What that means is it'll start at the bottom and work its way up. For the amplitude number outside, so our amplitude is 3, period, 2 pi divided by b, which in this case is pi. So we have a period of 2. We do not have a vertical shift. We do not have a phase shift because nothing is being added or subtracted. So our period is 2. Divide up our graph accordingly. Our amplitude is 3, which means the top of our graph will be at 3. The bottom of our graph will be at -3. So all this sets up the same as sine. We can even do the dotted lines for our top, middle, and bottom of the graph. So now we just use the pattern. Cosine starts at the top, so here's where it's different than sine. However, there's a reflection, so this one should start at the bottom. So cosine will always either start at the top or the bottom. Now we just move along. 1 tick mark over to 1/2. We jump up to the middle because the amplitude's 3, so we jump up 3. Move over again, jump up 3, jump back down 3, back to the bottom. Same going the other way. Just a matter of following that pattern. Connect your dots, and you have your cosine graph. For this next one, that negative is on the inside, which means that we are not going to graph a reflection. This would have been a reflection over the y-axis, which means the cosine graph would just land on itself. So we can just write none here. We don't have a reflection to graph. So next, our amplitude is the number outside. It's the amplitude of 4. The period is just 2 pi. So the b value is just 1. For the vertical shift, we have that -1 on the outside, so we're going down 1. And then the phase shift, be careful, remember it's c over b, well the opposite of c over b. So we're doing -pi, and here's where that negative does come into play, over -1, which means we are just going to start at pi. So there's a phase shift of right pi. So while this negative may not affect the reflection, it will still affect that phase shift when you do the c divided by b. So now putting everything in place, period of 2 pi means the graph divides up just as the parent graph does. Okay, our vertical shift is down 1, so our new center of our graph will be at -1. amplitude of 4, so our top of the graph will be at 1, 3, up at 3. Bottom of our graph, 1, 2, 3, 4, down at -5. And then lastly, our phase shift, we are moving pi to the right. So we are going to start, the starting point will be at pi. So now it's just a matter of following that pattern again. This one does not have a reflection, so cosine is going to start at the top. So we have a point at pi 3. And then as we move to the side, we go down to the middle, down to the bottom. Same the other way, middle, bottom, then back up, middle, top, middle, bottom. And there you have your cosine graph. So once you know the pattern, it's the same process as sine, just a different starting spot. So in summary for these graphs, you just have to know their main pattern and then how the transformations work. So for sine, the main thing you want to remember is it starts in the middle. Then I'm going to divide this up into fourths. It goes up to the top, middle, bottom, middle. That is your pattern that sine will always follow. For cosine, it always starts at the top and then goes middle, bottom, middle, top. These graphs look exactly the same on a broad scheme, so to be able to graph them, it's just a matter of knowing that pattern. Transformations work all the same except for the fact that a negative on the inside does not change the cosine graph. Otherwise, so we can do sine of -x and negative sine of x. Both make the graph go down first and then come back up. For cosine, it is only cosine of -x, and it has the graph start at the bottom and then follows that same pattern.